Hi, I'm Tracy Delgado, and today will be my first individual teach for Math for Teachers 2. And I will start out with a joke. Why can you not trust the math teacher holding graphing paper? They must be plotting something. So with that, let's start our first lesson. This is called Module 1, Chapter 8, Algebraic Reasoning, Graphing, and Connections with Geometry. And I added some cool pictures here. I hope we don't have to graph anything like this semester because that looks very hard to explain. And here's our graphing calculator. In this first one, we are given a line that looks really intimidating if you don't know what you're trying to do. You're just looking at like, well, okay, what does this represent? Our y-axis is the line going up and down, and our x-axis is the ones going across. In this case, we're going to show and explain the function of the amount of gas in a gas tank when a driver refills the tank on a drive across country. Our x-axis is the distance traveled in miles, and the y-axis is the amount of gas that we use. When we start out, the car is not moving because we already have the gas in the car. We're not traveling anywhere, so we're not using anything. As we start driving, our amount of gas goes down and the distance goes up. And when we fill up here, our gas goes up, but the distance doesn't change. And then as we get on the road again, we like to look at it that way. Our amount of gas goes down, but our miles starts going further because we are actually traveling. In our next one, we have like a little squiggly line going up and down. And the x-axis in this case will represent time. Our y-axis represents the number of floors. And I use a little lightning bolt to represent how it's going. This first line here is where you're just getting on the elevator. And then as it goes up, this is your first floor, I would say. And this is the time that we're going up. We'll stay on each floor. As we go up and up, the time, the steadily just moves on up. This next one, we're going to show and explain the function of the height of a bouncing ball dropped from a table. And we have this little, looks like a sideways tornado is how I would explain it. Our x-axis is going to be the number of bounces that we have, and the y-axis is the height of the bounces. And this is going to be our ball. This is where we're at the table. We have not bounced it yet. Okay, we're going to give it a really good bounce. And as it goes, this is going to be our first bounce. And this is the height. This is the highest that it will be because gravity will steadily work against us. This will be the highest, and it'll just gradually work its way down over as many as when we go for the number of bounces that we have. It's 1, 2, 3, 4. We're going to have 5 bounces according to this chart. And the last one, we're going to explain the function of the length of the shadow of a flagpole length of the shadow of a flagpole throughout a sunny day. And this one, the same thing. This is our y-axis, x-axis. Our x-axis is the time of day. Our y-axis is the length of the shadow. And I put a little sunshine here. And this is when we start out at the day. And as the sun rises, the length of the shadow steadily goes up. And then as the day progresses and goes down, the shadow, the line goes down, the length of the shadow. And this one, it's a bunch of words, but we're basically just going to be finding f of x equals f times g of x. In this case, the f of x equals 3x, and g of x equals x plus 8. And this one, our x will be 0, 1, 2, and 3. Excuse me. And here's our chart that I made up. This is our x, what all these represent. So we will just steadily just start adding. multiplying, but it's still, we're going to figure this out. I'm so sorry. 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. And 3 times 3 is 9. And in this one, we're going to find the g of x equals x plus 8. So we're going to do 0 plus 8 equals 8. 3 plus 8 is 11. 6 plus 8 is 14. And 9 plus 8 is 17. And this is what our lines will look like. This darker yellow, I would call it, is our f of x equals 3x. And this peachy colored is our g of x equals x plus 8. Okay, and this one we're going to show the slopes of the line segments determined by the given pairs of points. We're going to show whether the segment is vertical, horizontal, slopes upward to the right, or slopes downward to the right. And I put our gradient slope formula. It's going to be x. Oh, I'm sorry. Y to 2 minus y of 1 divided by x to 2 minus x of 1. And when we write it, it will be like a triangle. That means change in y divided by the change in x. And the first one, we had P and Q. That's the same thing, just x and y. It's just letters. We're going to do the exact same thing. Our change in y over change of x equals 5. This is our y of 2, and this is our y of 1. 5 minus 1 equals 4. Our x of 2 is 5, and our x of 1 is 3. 5 minus 3 equals 2. 4 divided by 2 gives us 2, so our slope is represented by m equals 2. And this is our line that we have graphed here. This is our 3, and this will be 5. And that's shown as going upward and to the right. So that's our slope. Our next one, the same thing, R and S. It's the same thing. Our change in y over change of x will be minus 8 equals negative 16. And our 5 minus 5 equals 0. So in this case, it's a negative number. So our slope is undefined. It's not going anywhere. It's just going up and down a vertical line. Okay, in this one we have U and V. And we're going to do the same way. We're going to do the change of y over the change of x equals minus 13 minus the negative 4, which gives us negative 9. Basically, these are being turned into plus signs. We have to a minus a negative number. And then our x of 2 is negative 4 minus negative 1. That gives us negative 3. So when you divide two negative numbers, negative 9 divided by negative 3 will give you a positive number. So we have 3. So our slope is 3. And it's going downward and to the left. Okay, and this next one we're going to show and explain the graph of the following functions and describe the similarities, differences, and relationships between the graphs. And these, when they're shaped like this, they're called parabolas. And this is our formula, how I worked these out. For that. Okay, our x, we have negative 2, negative 1, 0, 1, and 2. And this we were given y equals x squared. Our second one is y equals x squared plus 7. And our third one is y equals x squared minus 7. And this one we can tell also that if it's going to go up and down, the plus sign means it will be going up, and the negative sign means it's going down. So our first one, we have negative 2 squared will be 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. And the next one, we have y equals x squared plus 7. So we're going to have 2 squared plus 7. Our 2 squared is 4, plus 7 is 11. Our 1 plus 7 is 8. 0 plus 7 is 7. 1 plus 7 is 8. And 4 plus 7 is 11. And this is going to be our x squared minus 7. Our 4 minus 7 equals -3. 1 minus 7 is -6. 0 minus 7 is -7. 1 minus 7 is -6. And 4 minus 7 is -3. So when we're going to plot our lines here, our y equals x squared is -2 and 4. So we have our -2 here, and 4 is right here. -1 and 1 is here. 0 and 0 is here. Our 1 and 1 is here. Our 2 and 4 is on this side on the right. And you can see when you're starting out on your x1, your x number is negative, it will be to the left. And as you become positive, it will go to the right, it will shift to the right. And this one, our x squared plus 7, we have -2 plus 7 is going to be 11. This is this line here. -1 and 8. This is this one. 0 and 7 is this. 1 and 8 is this part. And 2 and 11 is this part. And then we have our x squared minus 7. All right, this is our -2, -3 plot here. -1, -6. This is this point here. 0 and -7. Our 1 and -6. And our 2 and -3. And when you first see it, it is intimidating, but once you have it in this chart, it really makes sense. And all you do is just, when you look at your graph, you just plug your numbers in. Okay, in this one, we're going to show and explain the equation of the line through the given point that is perpendicular to the given line. And in this case, the slope of the perpendicular line is the negative reciprocal of the slope of the given line if the given line is neither vertical nor horizontal. Okay, in this one, our y equals -3/4 x plus 5, and the r is 6 and -1. And the point slope formula, I looked this up, is y minus y1 equals m times x minus x1. So in this one, we have y minus the -1 equals 4/3 times x minus 6. Our y plus 1 equals 4/3 times x minus 6. Because as I said before, when you have minus a negative number, it makes it positive. Okay, in this one, we're going to have y plus 1 equals 4/3 x minus 24/3. Y plus 1 equals 4/3 x minus 8. And then we have y. Goodness, sorry, that just went blank on me. Okay, and this is the chart that I plugged in, did calculations. And this is what I came up with. And these are, all these numbers are what these dots represent. And this is where these lines intersect, is this section right here. This next one, we have 2y plus 9x minus 5 equals 0. And the s is 0 and 3. We have 2y plus 9x minus 5. And we're trying to get the x, we're trying to isolate the y on the left. 2y minus 5 equals -9x. 2y minus 5 plus 5 equals 9x plus 5. And as you can see right here, whatever you do on the left side, you must do on the right side. 2y equals -9x plus 5. And then finally, we have y equals -9/2x plus 5. So our slope is the -9/2. And there's our point slope formula again. Y minus 3 equals 2/9 times x minus 0. Y minus 3 equals 2/9x minus 0. Y equals 2/9x minus 3. And this is my calculations here. And this is my graph. And right here is where they're going to intersect, right there. All right, this one, we're going to show and explain the equation of the line that is tangent to the circle of radius 9 at 0 and -9, and whose center is at the origin. We will show and explain the equation of the line that is tangent to the circle of radius 9 at 0 and 9, and whose center is at the origin. Then we're going to compare the line in part B to the line in part A. Okay, so here's our x and y. X, in this case, is -9 and 0, 9 and 0. And y, we just flipped it around, 0, 9, 0, and -9. We reverse the order if you want to look at it this way. Okay, and this is our x and y axis here, and here's our circle. And when they have our lines here, the 0 and -9 is here at the bottom. And then our 0 and +9 is up here above it. And it just shows that they're horizontal lines. And that is the end of my video. I apologize for any mistakes I made during this video. As I told you before, I was very nervous during this team teach. I'm sorry, my individual teach. I promise it will be better during my team teach. With that being said, this is over. I will see you the next time. Bye. Ugh, horrible.